Welcome to David Alexander Maths Tuition. This is Chapter 8D, Solving Binomial Problems. Find the coefficient of x cubed in the binomial expansion of 5 plus x to the power of 5. Okay, so the first term is going to be 5 to the power of 5. The next term is going to be 5 choose 1 times by 5 to the power of 4 times by x. The next term is 5 choose 2 times 5 cubed times x squared. The next term is 5 choose 3, 5 squared x cubed. Right, okay, so we don't need to do the full expansion, we just want the coefficient of the x cubed. So the coefficient of the x cubed is simply 5 choose 3 times 5 squared, or times 25. So grab the calculator. What is 5 choose 3? That is 10 times 25, so that is 250. Okay, here's another example. The coefficient of x squared in the binomial expansion of blah is this horrendous number here. Find the possible values of the constant a. Okay, so it's 5 plus ax. Okay, so the first term is going to be 5 to the power of 6. The second term is going to be 6 choose 1, 5 to the 5 times by ax. The next term is 6 choose 2, 5 to the 4, and it will be ax squared, and we just need to remember that that is the same as a squared x squared. So I'll write a squared x squared there. The next term is going to be 6 choose 3, 5 to the 3, a cubed x cubed, etc, etc. Now we've already gone further than we needed to go, so we're interested in the coefficient of the x squared. So 6 choose 2 times by 5 to the power of 4 multiplied by a squared, that is the coefficient of x squared, and we've been told that the coefficient of x squared is that number there. So therefore 6 choose 2 times 5 to the 4 times a squared is 234,375. Well, what is 6 choose 2 multiplied by 5 to the power of 4? Well, 6 choose 2 is 15 times by 5 to the power of 4 is 9375. So 9375, lots of a squared is this 234,375. So therefore a squared is the 234,375 divided by the 9375, and a squared is 25. So therefore a is going to be the square root of 25. So a is 5 or a is negative 5. And if you wanted to test it, turn this into 5 plus 5x or 5 minus 5x to the power of 6. Do the expansion and you'll see that the coefficient of x squared, whether you use it as minus 5 or plus 5, will indeed be 234,375. I probably wouldn't bother if I were you. That sounds like a lot of work. If you got the half decent skills at doing the binomial expansion, then I'm pretty certain you will have got it correct. Okay, this one's a little bit harder because of the introduction of this other 5 plus x bracket. So I'm just going to ignore the 5 plus x bracket for now, and I'm going to do my binomial expansion on the 3 minus bx to the power of 5. So if I were to expand that, I would have 3 to the power of 5 plus 5 choose 1 times 3 to the power of 4 times negative bx plus 5 choose 2, 3 cubed, now minus bx squared. Now that would be, we need to be careful here, minus bx all squared, that is the same as negative b squared x squared, which is b squared x squared, plus 5 choose 3, 3 squared, and here it's going to be, need to be careful here, so it's minus b cubed, so that's going to be minus b cubed, lots of x cubes, and I could carry on, but I'm going beyond the x cubes. Okay, so this is the expansion, or a partial expansion, of 3 minus bx to the power of 5. Again, I've not bothered with a b to the power of 4, b to the power of 5, because we're interested in the cubed term. Now this is going to be multiplied by 5 plus x. Now if I were to multiply all of this by 5, if I multiply the 3 to the power of 5 by 5, has that got anything to do with the coefficient of x cubed? No, it hasn't. We'll just get a random number. What about if I multiply this part here by the 5? Is that even necessary? Well, no, it's not, because that won't give me an x cubed term. That will just give me a certain number of x's. Similarly, there's no point multiplying this by 5, because I'll just get a certain number of x squared. I'm not interested in the x squared. However, if I multiply this one by the 5, then that will get me a certain amount of x cubes. So again, we just want to reduce the, well, what's the point in doing work we don't need to do? So 5 choose 3 is 10 times 3 squared multiplied by the 5 from that other bracket. That is 450 times minus b cubed. So I'm going to write minus 450 b cubed x cubed. Okay, so I can't say that this is minus 24480 because I've not multiplied all of this stuff by the x yet. Now, if I'm only interested in x cubed terms, the only way I'm going to get an x cubed term when I multiply this big bracket by x is by multiplying the x squared by the x to give me an x cubed term. Okay, I mean, I could do 3 to the power of 5 times x, but that would just give me an x. I can multiply the 5 choose 1, 3 to the 4 minus bx by an x, but that will only give me an x squared. But by multiplying this x squared by the x, that will give me the x cubed. Again, if that sounds confusing, you could just multiply, I mean, if you wanted to, you could do the full expansion of 3 minus bx to the power of 5 and then multiply the whole thing by 5 and the whole thing by x, tidy it up, and then isolate the x cubed term. But this just saves a lot of unnecessary work. So 5 choose 2 is 10 times 3 cubed is 270, so that is plus 270 b squared x cubed. Okay, so what I have here, so my coefficient for the x cubed is minus 450 b cubed plus 270 b squared, and we've been told that that equals minus 24480. Okay, so what I'm going to do is I am going to solve this as a cubic equation. So that's negative 450 b cubed plus 270 b squared plus 24480 and make that equal 0. And now I'm going to use my quadratic equation solver. Well, it's not quadratic, it's a cubic. So the polynomial degree is 3. So I can type in minus 450 on my calculator. It would be an x cubed, not a b cubed. That doesn't matter. 270 x squared, 0 x's, and then 24480 at the end. Press enter, and we see that b equals 4. Are there any other values? No, I'm just getting an imaginary number for my x2 and also my x3. So there we go. So b is 4. A bit of a tricky one, that one. Again, some people might have struggled about the reason why I only multiplied the 5 by the 5 choose 3, 3 squared minus b cubed x cubed, and I only multiplied x by the this term here. Again, it's because all I'm interested in is x cubed terms, and because I'm quite a lazy person and also I don't trust myself to get maths right all the time, I want to minimize the amount of work I'm doing due to laziness and due to the fact that I might get stuff wrong. What's the point in A, doing stuff that's unnecessary, and B, stuff that you might get wrong? Focus on the minimum bits, which is multiplying a cubed term by 5 and a squared term by x to get the number of x cubes. Hope that makes sense. Okay, so a bit like the previous example, we are only interested in x to the power of 2 and x to the power of 1s. So if I do my binomial expansion, I'm going to get 2 to the power of 11 plus 11 choose 1, 2 to the power of 10 times by ax plus 11 choose 2, times 2 to the power of 9a squared x squared. Okay, so here's my x term, here's my x squared term. Let's do some calculations. So 11 choose 1 is 11 times by 2 to the power of 10. So we're going to get a fairly big number here. So 11264ax plus 11 choose 2, which is 55, times 2 to the power of 9. That is 28160. 28,160 a squared x squared. Okay, so we've been told that the coefficient of x squared is 17.5 times bigger than the coefficient of x. So this part here, including the a, when I multiply that, so 11264a, when I multiply that by 17.5, that is going to equal 28160a squared. Okay, so I'll do this fairly slowly and steadily. 11264 multiplied by 17.5 is 197120. A is the same as 28160a squared. So we can divide both sides by a and divide both sides by 28160. So therefore a, hopefully this will come to a fairly nice number. Yeah, it does. Fantastic. So a is 7. There we go. So all you need to do here is just work out, well, you didn't even need the 2 to the power of 11 really, but I always feel like that's a good way to get the questions started. We just wanted the x term and the x squared term, and just be careful with which one's bigger. Well, we know that the x squared term is 17.5 times greater, so that means that the x term has to be multiplied by 17.5 times in order to equal the x squared term.